All right, welcome everyone. Today we're going to discuss the nature of science, and by the end of this video, you should be able to explain why it's important that we understand the process scientists use to discover truths about the world. Let's go ahead and start. Why should you care about science? Well, once you understand what the word science actually means, the answer becomes pretty simple. So, our word science comes from the Latin word for knowledge. So basically, science is this method we use to gain knowledge of the physical world. And why is it important that we have knowledge of the physical world? Well, that kind of knowledge can be really useful. So pause for just a moment and think, why would it be a good thing for me to have knowledge of the world around me? I can think of a couple of examples. So, one, it would help us predict the future. And you might be like, whoa, we can predict the future? Yeah. Think, for example, of the weather. If I know what causes it to rain or what causes it to snow, then I can look at weather patterns and predict, hey, in a week, it's going to be a huge snowstorm. And that knowledge is really useful. Also, this kind of knowledge of the physical world would increase our quality of life. So think of medicine. When we understand what germs are and that they can cause various illnesses, we can develop treatments and that brings people better health. So that's really useful knowledge to have as well. Now, you might be surprised, but you actually use this method that we're calling science all the time, and you may not have even realized it. So let me try to explain with a really practical example of something I know that has happened to you at some point in time. Inevitably, you have plugged your phone in and let it charge, and you come back and it's still dead. The phone's not charged at all. And you wonder why. Well, this is really important actually. So notice that you just made an observation, okay? So you came to your phone and you looked and you saw that the battery was dead. That is an observation. And that's the very first thing that scientists use in this process of discovering truths about the physical world. The second thing that you did was you asked a question. Why is it that even though my phone was plugged in, it didn't charge? So that's the second step in this process. And then you actually designed an experiment. You may not have realized it, but you actually began forming hypotheses. And you might think, I formed a hypothesis? What? Well, just think of a hypothesis as a prediction. Okay, you made a prediction here. And what you did was you said, look, either my charger is broken, maybe that's what caused the problem, or maybe it was the outlet in the wall. Maybe that's not working and that's causing the problem. Or maybe something's wrong with my phone. So my phone is broken and that's causing the problem. All right. Each one of those is a hypothesis. And one of these is causing the problem. And I want to emphasize the word causing. Okay. One of these was causing your phone not to charge. Now, whatever we think is causing something in an experiment, we're referring to that, or scientists refer to that, as an independent variable. So whenever you see that word independent variable, think cause. It's supposed to cause something else to happen. Now, let's say that you decide, okay, I'm going to see if it was my charger. Maybe my charger's broken. So we're going to start with that one. Okay? You pick that independent variable and you're going to test it, which is our very next step. You test your hypothesis. So you go out, you buy a new charger, and you plug it into your phone, and you come back in a few minutes and you look and your phone is still isn't charging. So when you are checking your phone, you're checking something specific. You're checking the battery. Okay, you want to see if the battery is charging. The thing that you're checking on is the effect. So by getting a new charger, that new charger was supposed to cause something to happen. It was supposed to cause the battery to begin to be charged. Okay, that new charger was supposed to cause some effect. The effect is the battery being charged. Whatever your effect is that you're looking at, that's your dependent variable. Okay, so when you test a hypothesis, you should always make sure you have an independent variable, the thing you think is causing something to happen, and then a dependent variable, some effect that you're going to check on. In this case, it's the battery. Now, in this case, you collect data. What's the data you're collecting? Well, you're looking at the life of the battery. You know, what percentage charge does it have? Well, this one, it's still dead. So that's the data you collected. The battery's still dead. So based on that data, you then should draw some conclusion. Okay? And so what do you think? Should we reject our hypothesis, or can we do we fail to reject it? What do you think? Our hypothesis was that the charger was the problem. So if we replaced it with a new one, then the battery would charge. Well, once you look at the results, you see, hey, I replaced the charger and my battery still didn't charge. So that means my original hypothesis, I have to reject it. That wasn't the correct hypothesis. Well, that means we need to go back and we need to test some new hypothesis because we still haven't solved the problem. We still don't know what was causing your phone not to charge. So we go and we pick out a different independent variable. Maybe we pick the outlet. Maybe we pick your phone. Okay. But we switch, we try out a new hypothesis, and then we follow the same steps that come after that. This is the scientific process. Okay. You go through observation, you form a question, you design an experiment around that question by making a hypothesis, testing the hypothesis, collecting the data, and then drawing some conclusion. Okay, and that is where our journey begins when we're trying to understand the nature of science.